Welcome to Falcon TV. Subscribe to the channel to stay informed and inspire us.
The multiverse is a term that scientists use to describe the idea that beyond the observable universe, other universes may exist as well. These universes could have different physical laws, constants, and histories from our own. There are different types and levels of multiverse theories, depending on the assumptions and evidence that support them. The evidence for the multiverse is not direct, but rather based on theoretical predictions and observations that suggest the possibility of other universes beyond our own. Some of the main sources of evidence are 1. The cosmic inflation theory, which proposes that our universe is one of many bubble universes that emerged from a rapid expansion of space after the Big Bang. These bubbles could have different properties and dimensions from ours. Some evidence for this theory comes from the cosmic microwave background, CMB, the oldest light in the universe, which shows tiny fluctuations in temperature and density that could be caused by quantum fluctuations during inflation. 2. The quantum mechanics theory, which suggests that every possible outcome of a quantum event creates a new branch of reality. This is also known as the many worlds interpretation. According to this theory, there are infinite parallel universes where every possibility is realized. Some evidence for this theory comes from the quantum interference experiments, such as the double-slit experiment, which show that particles can behave like waves and interfere with each other, implying that they exist in superpositions of multiple states until they are observed. 3. The string theory or M theory, which posits that our universe is one of many membranes or brins that exist in a higher dimensional space. These brins could collide or vibrate, creating different universes with different physical laws. Some evidence for this theory comes from the gravitational waves detected by the LIGO and Virgo observatories, which could be caused by collisions or oscillations of brins in the extra dimensions. 4. The mathematical universe hypothesis, which argues that every mathematical structure is a possible universe, and that our universe is just one of them. This implies that there are uncountably many universes, some of which are completely abstract and incomprehensible to us. Some evidence for this hypothesis comes from the fine-tuning problem, which asks why the fundamental constants of nature are so precisely set to allow for life and complexity in our universe. One possible answer is that there are many other universes with different values of these constants, and we just happen to live in one that is compatible with our existence. The idea of the multiverse, or the existence of multiple universes, has been proposed by various thinkers and scientists throughout history. However, the term multiverse was first coined by the American philosopher and psychologist William James in 1895. He used it to refer to the different ways of interpreting natural phenomena, not to other possible worlds. One of the earliest proponents of the multiverse as a physical reality was the American physicist Hugh Everett, who developed the many worlds interpretation of quantum mechanics in 1954. He suggested that every possible outcome of a quantum event creates a new branch of reality, and that there are infinite parallel universes where every possibility is realized. Another influential contributor to the multiverse theory was the British physicist Stephen Hawking, who proposed the no-boundary condition for the origin of the universe in 1983. He argued that the universe could have emerged from a quantum fluctuation in a timeless and spaceless state, and that there could be many such universes with different initial conditions. There are also other types and levels of multiverse theories, based on different assumptions and models from cosmology, string theory, mathematics, and philosophy. Some of the main types are 1. Level 1, an extension of our universe, where regions beyond our observable horizon have different configurations of matter and energy. 5. 2. Level 2, universes with different physical constants, where regions of space undergo different phases of inflation and have different laws of nature. 5. 3. Level 3, many worlds interpretation of quantum mechanics, where every quantum event splits the universe into multiple branches. 5. 4. Level 4, ultimate ensemble, where every mathematical structure is a possible universe, and our universe is just one of them. Let's understand the universe. The universe is everything that exists, including all matter, energy, and space, and is vast and contains billions of galaxies, each of which contains billions of stars. A galaxy is a vast system of stars, gas, dust, and other celestial objects bound together by gravity. Our galaxy is called the Milky Way and has more than 200 billion stars. Space is the physical expanse in which everything exists, including our planet, stars and galaxies. Space has boundaries defined by celestial objects such as planets or stars. The universe is a very big and complex topic, but I will try to explain it as much as I can. The universe is everything that exists, including all matter, energy, space, and time. The universe has no edge or center, and it may be infinite in size. The universe is also expanding, meaning that the space between galaxies is getting larger over time. The universe is composed of many different types of objects and phenomena, such as planets, stars, galaxies, black holes, dark matter, dark energy, and more. The universe is also governed by physical laws and constants that describe how these objects and phenomena interact with each other. One of the main ways that scientists study the universe is by observing the light and other forms of radiation that come from distant objects. By analyzing this light, scientists can learn about the properties, history, and evolution of these objects. For example, scientists can measure the distance, temperature, composition, motion, and age of stars and galaxies by looking at their spectra, which are the patterns of colors and wavelengths that they emit or absorb. Scientists can also use telescopes and satellites to detect other types of radiation, such as radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays, that reveal different aspects of the universe. Another way that scientists study the universe is by using mathematical models and theories that try to explain how the universe works. One of the most important theories in modern cosmology is the Big Bang theory, which states that the universe began about 13.8 billion years ago from a very hot and dense state of matter and energy. The Big Bang theory is supported by several observations, such as the cosmic microwave background, CMB, which is the leftover radiation from the early universe, the abundance of light elements, hydrogen, helium, and lithium, which were created in the first few minutes after the Big Bang, and the redshift of distant galaxies, which indicates that they are moving away from us due to the expansion of the universe. However, there are still many questions and mysteries about the universe that scientists do not fully understand or agree on. For example, what caused the Big Bang? What is the nature and origin of dark matter and dark energy? Are there other universes beyond our own? How will the universe end? These are some of the challenges and opportunities for future research and exploration in cosmology. Here is what James Webb Telescope has seen in our universe. The James Webb Space Telescope, JWST, is a powerful and advanced space observatory that was launched by NASA in 2022. It is designed to study the universe in infrared light, which can reveal hidden details and structures that are invisible to optical telescopes. JWST has a large mirror of 6.5 meters in diameter, and 4 scientific instruments that can observe a wide range of wavelengths, from 0.6 to 28 micrometers. JWST can also operate at very low temperatures, around 223 degrees Celsius, which reduces the interference from its own heat. JWST has seen many amazing and fascinating things in our universe since it began its scientific operations in 2023. Some of the highlights are: JWST captured stunning images of the Whirlpool Galaxy, one of the best-looking, grand design, spiral galaxies in the night sky. The Whirlpool Galaxy, also known as M5, is located about a million light-years away from Earth, and has a smaller companion galaxy that is gravitationally interacting with it. JWST revealed new star clusters forming in the spiral arms of the galaxy, as well as dust lanes and gas clouds that are sculpted by the tidal forces of the companion galaxy. JWST revealed intricate details in the remains of a dying star, known as the Ring Nebula. The Ring Nebula, also known as M57, is one of the best-known examples of a planetary nebula, which is a shell of gas and dust ejected by a star at the end of its life. The Ring Nebula is located about 2,000 light-years away from Earth, and has a diameter of about 1 light-year. JWST showed the complex structure and composition of the nebula, including clumpy gas and dust, ionized elements, and shock waves. JWST obtained images of the Crab Nebula, one of the most famous supernova remnants in our galaxy. The Crab Nebula, also known as M, is the result of a massive star explosion that was observed by Chinese astronomers in 1054 AD. The Crab Nebula is located about 6,500 light-years away from Earth, and has a diameter of about 11 light-years. JWST showed the dynamic and colorful nature of the nebula, including pulsating jets, expanding filaments, and glowing synchrotron radiation. JWST detected signs of water vapor on an exoplanet for the first time. An exoplanet is a planet that orbits a star other than our Sun. JWST observed an exoplanet called K218b, which is located about 124 light-years away from Earth, and has a mass and radius similar to Neptune. JWST used its spectroscopic capabilities to measure the chemical composition of the planet's atmosphere, and found evidence of water vapor, as well as hydrogen and helium. There are some theories and models that suggest this possibility. However, there are also many challenges and limitations to testing or verifying these theories. One of the most popular theories about black holes as portals to other universes is the multiverse theory. This theory suggests that there may be multiple universes, each with its own set of physical laws and constants. According to the multiverse theory, black holes could be the gateways between these different universes. Another theory that proposes black holes as portals to other universes is the wormhole theory. This theory posits that black holes are actually tunnels between two regions of space and time, which could be in the same or different universes. According to the wormhole theory, black holes are not singularities, but rather have a white hole at the other end, where matter and energy can escape too. However, both of these theories face many difficulties and criticisms. For example, how can we observe or communicate with other universes through black holes? How can we avoid the extreme gravity and radiation near the event horizon of a black hole? How can we account for the conservation of mass and energy in the process of traveling through a black hole? How can we reconcile these theories with the existing laws of physics and cosmology? Therefore, the question of whether black holes are portals to other universes is not settled, but rather an open and fascinating topic for research and exploration. However, none of these sources of evidence are conclusive or definitive, and there are many challenges and criticisms to the multiverse theories. For example, some scientists argue that the multiverse is not falsifiable or testable, and therefore not scientific. Others question the validity and consistency of the assumptions and models that lead to the multiverse predictions. And some philosophers wonder about the implications and meaning of the multiverse for our understanding of reality and existence. Therefore, the evidence for the multiverse is not definitive, but rather suggestive and speculative. It is possible that there are other universes out there, but it is also possible that we will never know for sure.
If you liked this video, please subscribe to the channel and give a thumbs up. Thank you.